Session Chair, distinguished guests, ladies and gentlemen, good morning. Our research is on the behavior of daily rainfall extremes in the context of climate change. Floods has been a prominent natural disaster in the world. So, I would like to start the presentation by comparing two reports. First one was taken from the Presidential Address, Sri Lanka Association of Advancement Sciences, in 1960 by prominent engineer Mr. Arumugam. He explained about the 1957 December flood and designated as a catastrophic flood and once in a 100-year or once in a 200-year flood. And one cannot prevent occurring of these kind of events. The next report was taken from the World Rivers Review in 2010. So after 15 years from 1960. So in this report it explains every month there are very rare storm events and flood events occur with severe frequency. Now when we compare these two, it's 1960 and 2010, so with a 50-year difference, still the story is same. So shall we look about some devastating floods occurred in the world, starting from Sri Lankan floods in 2010 and 2011 in Colombo, Eastern Province and North Central Province. In Australia, mainly in Queensland, December 2010 and January 2011. And also you can see Pakistan and Brazil flood. Not only those two floods, but those 2 years, but in recent floods, say in this year, in 2012, in China's capital, Beijing. So let me talk about some extremes. And again, I'm taking World Rivers Review. So they explained about Three Gorges Dam in China, and the dam was designed to withstand 1 in 10,000 years flood in 2003. And then with those extremes, it was reduced into 1 in 1,000 years in 2007. So after again 1 year, that is in 2008, it was further reduced to 1 in 100 years. Then if you refer IAHS newsletter, it also states many water-related extremes become more frequent and more severe. And if you refer IPCC Technical Report 6, it says generally numbers of heavy daily precipitation events that lead to flooding have increased, but not everywhere. So we had to think about that. Then what has happened in Sri Lanka? So I'm taking this article from Daily News in 2010. The title of the article is Dry Zone Invades Wet Zone. So what does it say? Dry zone is gradually extending into the wet zone. So which implies in some areas of the wet zone may be the decrease in rainfall. We'll see. Then this flood, the catastrophic flood. So after a dry spell of 20 months, the torrential rain occurred on 24th and 25th of December. So the serious damage, nearly 35 major irrigation tanks with 1,300 village tanks. You can see the spilling of Nachaduwa, and not only Nachaduwa, Kalawewa, Puruluwewa, those things damaged. So another historical floods in 1907, 1978, Batiklo, and 1947 major flood in Ratnapura, and 1992 flood in Colombo. I think some of you can remember those things. In 2003, so not only in one area, but occurred in Ratnapura district, Kaluthura district, and southern province. Let's go to 2010 November flood in Colombo. So that's the second largest daily or 24-hour rainfall in Colombo time series. the value is 440 millimeters. The daily rainfall is 440 millimeters. But the maximum value occurred in Colombo is 492 in 1992. So you can see about the damage. You can see what happened to our parliament. So 200,000 people displaced here. Now, after 2 months, in January 2011, again you can see what has happened in Nachadua, spilling. The same month, January 2011, at Beticlo, the highest monthly rainfall. Monthly rainfall in January in that year is 1,368. But if you compare this one with the average annual rainfall in Beticlo is 1,500. You can see what has happened. In monthly rainfall, 1,368, and the annual rainfall is, average annual rainfall is 1,500. And this was the third highest daily rainfall, Beticlo. Nearly 1 million affected, 62 lives lost, 200 persons displaced. And also, Senanayaka Samudra spilled after 16 years. Now, you may think, what is the change in rainfall? Is there any pattern? Yes, this is the question, whether a trend exists in extreme rainfall time series in Sri Lanka. Now, if you analyze change in rainfall, there are so many ways. You have to think about the amount, the value, whether it is 100 millimeter daily rainfall or 300 millimeter rainfall at particular station. Or are we thinking about intensity? It's millimeters per hour. That is, maybe amount is same, but intensity can be increased at several areas. And then the duration. So we have to specify the duration, whether it is a daily rainfall, monthly or annual rainfall. And then timing. So when it will be occurred. Maybe it's a seasonal rainfall, southwest monsoon or northeast monsoon. Now, the objective of this research is to investigate whether a trend exists in extreme rainfall at several Sri Lankan stations located in different climatic zones. So those are some literature regarding trend analysis done in Sri Lanka. You can see all of those are limited to monthly and annual rainfall series. So there's increase in trend in monthly rainfall at Colombo. Again, seasonal rainfall, increase in trend at Colombo, not only Colombo, but Puttalam and Hambantota. There's a decrease in trend in annual rainfall at Nuwara and Wattawala. So in this research, I have selected 6 principal meteorological stations covering dry and wet zones. And you can see the total length, it's so lengthy record, and you can see the continuous record as well. Because to do a statistical analysis, we need a continuous lengthy record at least 30 years. And the last 2 columns shows the maximum daily rainfall occurred in each station with the date of occurrence. So you can see as an example, Hambantota, which is in the dry zone, the maximum daily rainfall is nearly 300 millimeters. And in this research, we are specially focusing about daily rainfall extremes. So that means we have analyzed annual daily rainfalls. To do the trend analysis, there are so many statistical tests. So before doing any statistical test, we have done visual examination. And we have selected 3 statistical tests: Spearman's Rho, Mann-Kendall, linear regression, which covers both parametric and non-parametric measures. So let's see one visual examination. This is for Colombo. So this is the time series, covers 1901 to 2005. And you can see an upward trend or increase in rainfall. So likewise, various other stations, Beticlo is neutral almost, Anuradhapura, decrease in rainfall, Galle, neutral, Hambantota, it's almost neutral, but Puttalam, increase in rainfall. So that is maybe a positive trend. So those are some visual examinations. Now let's think about statistical tests, the results. So first we will take Spearman's row correlation test. And it shows the rank correlation, and the next column is for the test statistic, and consider the 95% confidence limit. So if the test statistic lies between the confidence limit, then there is no significant trend. So you can see there is no significant trend at all 6 stations. But there's an interesting point again. At Anuradhapura, Colombo and Puttalam, if you carefully look, the test statistic is close to the limits. And Anuradhapura, it's a negative trend. You can see a minus sign. So it's decrease in rainfall. And if you take Colombo and Puttalam, those are positive trends, increase in rainfall. So let's see what's happened in the next test. So that is Mann-Kendall test. Again, the similar kind of result. Colombo and Puttalam, you can see increase in rainfall. So that is positive trend. Let's see what's happened in linear regression. The same result. No significant trends at all stations, but Anuradhapura, negative trend, Colombo and Puttalam, positive trends. Now, with those results, and we have experienced some severe events in 2010, Colombo, and 2011, Batiklo, we thought to include those very recent data in our time series. Now you can see time series after including recent data. And the black round shows you the very recent data, that is from 2006 to 2011. And if you compare the total time series, there are 4 high values which exceeds 300 millimeter daily rainfall. And out of those 4 values, 3 values are within the last 50 years. So maybe we didn't expect a trend, but within the last 50 years, we don't know whether any trend exists in future. So in our concept, more severe, more frequent, maybe we can expect. So next goes to Colombo. So in this time series, again, we have included data from 2006 to 2010, and which gives the second highest rainfall. So you can see the high values, 2 high values which exceeds 400 millimeter. So that is daily rainfall greater than 400 millimeter. And there's no value in between 300 to 400. And it's very clear, you can see a positive trend. So within last 18 years, again you can see a trend. So we can go to the concept, more severe, more frequent rainstorms. So this, interestingly, what has happened at Colombo? All 3 tests show an increase in trend which is significant, but earlier it is non-significant. But after including very recent data, it's significant at 95% confidence level. So coming to the conclusion, statistically significant trends were not detected if we use data until 2005. But if we include data 2006 to 2010, only Colombo shows a significant increase in trend. So, at various places across the country, maybe we have increase in trend, decrease in trend, and sometimes it might be neutral. So, the impact of climate change on extreme rainfalls could be different. And finally, in the context of sustainable development, there's a need for monitoring of extreme rainfalls. Thank you.